Section 3.2, Measures of Variation. Variation is the single most important topic in statistics, so this is the single most important section in the book. This section presents three measures of variation: range, standard deviation, and variance. These statistics are numbers, but our focus is not just on computing, but on developing the ability to interpret and understand them. The round-off rule for measures of variation, similar to what we had in the last section for measures of center, will carry one more decimal place than is present in the original set of data. The range of its set of data is the difference between the maximum and the minimum. The range uses only the maximum and the minimum, so it's very sensitive to extreme values. The range is not resistant. Because the range only uses the max and the minimum, it doesn't take every value into account and therefore does not truly reflect the variation among all of the data values. Find the range of the Verizon data speeds. So the solution here, we take the maximum 55.6, subtract the minimum 14.1, and we get a range of 41.5. The standard deviation is a set of sample values denoted by S, a measure of how far each data value deviates from the mean. And we're going to use S for the sample standard deviation and the Greek letter sigma for the population standard deviation. The formula for the standard deviation is shown here. We will use technology, but it's important for you to understand where the formula comes from. In the numerator, each data value, the distance between the data value and the mean is measured. It's squared. They're added up, divide by n minus 1, and then take the square root. The standard deviation, again, is a measure of how much the data values deviate from the mean. The value of the standard deviation is never negative. And if I go back to the formulas for a minute, the reason for that is because we've got a square here, so we can't have a negative value. It's never negative. It's 0 when all the data values are exactly the same. Larger values of S indicate greater amounts of variation. The standard deviation S can increase dramatically with one or more outliers. Therefore, we say it's not resistant. The units of the standard deviation are the same as the units of the original data values. The sample standard deviation S is a biased estimator of the population standard deviation, which means the values of the sample standard deviation do not center around the value of sigma. Use the sample standard deviation formula to find the standard deviation of the Verizon data speeds. So our mean for that sample was 30.7. And so we take each data value, subtract the mean, square the differences, add them up. There's 5 data values, so 5 minus 1 is 4. We divide the sum of the squared deviations, divide by 4, and then take the square root, and we come out with a standard deviation of 16.45. And there's a shortcut formula if you're going to do it by hand, but I don't think you want to do it by hand. Again, we're going to use technology. We'll use StatCrunch. The range rule of thumb is a crude but simple tool for understanding and interpreting standard deviation. The vast majority, such as 95% of data values, will lie within 2 standard deviations of the mean. Significantly low values are values in the data set that are less than 2 standard deviations below the mean. Significantly high are data values that are more than 2 standard deviations above the mean. Values within 2 standard deviations of the mean are not significant. The range rule of thumb for estimating value of the standard deviation is to take the range and divide by 4, and it will give an approximation of the sample standard deviation. The standard deviation of a population is similar to the formula for the standard deviation of a mean. However, if you notice, in the numerator, we take each data value and subtract the population mean, and in the denominator, we divide by the sample size for the population n. We don't make a correction like we did for the sample standard deviation. We just divide by the total population size. The variance is a set of values. Again, a variation is the square of the standard deviation. It's actually the quantity under the square root sign when we calculate the standard deviation. So we have S for the sample standard deviation, S squared is the sample variance, sigma is the population standard deviation, and sigma squared is the population variance. The units of the variance are squares of the units of the original data values. The value of the variance can increase dramatically with the inclusion of outliers, so again, we say the variance is not resistant. The value of the variance is negative. It can be 0 when all the data values are the same. And sample variance is an unbiased estimator of the population variance. Why do we divide by n-1 when we calculate the sample standard deviation or the sample variance? Because there are only n-1 values that can be assigned without constraint. With a given mean, we can use any numbers for the first n values, n-1 values, but the last value would be automatically determined. Empirical rule for data with a bell-shaped curve tells us this: 68% of the data will fall within 1 standard deviation of the mean, 95% of the values will fall within 2 standard deviations of the mean, and 99.7, or almost all of the data values, will fall within 3 standard deviations of the mean. And there's a picture of what the empirical rule looks like. So approximately 68% will be with 1 standard deviation of the mean, approximately 95% within 2 standard deviations, and approximately 99.7% of the data will be within 3 standard deviations. IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. What percentage of IQ scores will fall between 70 and 130? The key to recognize is that 70 and 30 are each 2 standard deviations away from the mean. If we go back, we notice that the standard deviation was 15, so 2 standard deviations would be 30. This is 2 standard deviations below, 2 standard deviations above. So this is going to be 95% of the IQ scores should fall between 70 and 130. The sample standard deviation, again, is a biased estimator of the population standard deviation. This means the values of the sample standard deviation do not tend to center around the value of the population standard deviation. However, the sample variance is an unbiased estimator of the population variance. There is a StatCrunch video in my courses that will show you how to use StatCrunch to calculate the range and the standard deviation and also the variance.